Hi everyone, thanks for sticking around after the panel discussion. As part of the sponsors, I was invited along to kind of talk about Leica Geosystems, and what I want to mention is more about, there's been some excellent work going on in the office, collaboration, coordinated models, using BIM in an office environment. Where Leica, we feel we can come in, is linking this office to the site, actually taking this rich, valuable data from the office and to the site and then back again. So that's where Leica comes in. So in terms of what's coming up, I'll very briefly talk about Leica if you haven't heard of us. I think most of you probably have. And then we'll look at what we're coining the BIM field trip, which is very similar to what Murphy's have got on their slides at the back in terms of BIM to field and field to BIM, so the full circle. And then we'll look at the three parts that we see it as: inform, so capturing the as-built environment. So this is renovation work, so the actual as-built before you even start the project. So that's looking at 3D laser scanning, and then looking at enriching data. So once we have this, once we have a digital model, a graphical model in the office, how do we use that to send information to the site for construction layout? So actually seamlessly sending information taken directly from the digital model straight into something like a total station to set out foundations or specific cuts on construction sites. And then we look at validate, which was a question that was brought up. How do we make sure what is constructed is actually what has been put in the digital model? So whatever's handed over to the client is accurate to what is actually constructed. And we're not talking about whether the right amount of information, but literally to the point where a pipe, is it in the right place, is it in the right room, is it in the right building, to that degree. And hopefully these kind of tools using total stations and laser scanners can really help you out there. So a very brief background on me. That's me, obviously. It's technical consultant. I've only been working at Leica for about 4 or 5 months. I joined from a UK survey company where I ran the 3D department, so I was very much involved in generating building information models for clients like yourselves from a survey point of view, so capturing the as-built environment and then converting that into a model that could be used in a BIM project. So some of the projects that I have worked on, I've worked for councils, I've worked for police authorities, I've worked for hospitals, and I've also worked for Tata Steel, doing various kind of quite large, everything from residential properties all the way up to kilometre-long factories. So in terms of Leica Geosystems, it is right that it's 200 years Leica have been around in some form, so we've got a little bit of experience in terms of solutions that capture, analyse and present spatial information. So we do a range of different products that are not just actual products, but we do software as well, and we very much get involved in a lot of stages that are involved in the construction process and now building information modelling. From the disto, which you probably all own and have in your drawer somewhere, all the way up to laser scanners and so forth, which is the output. I'm guessing you guys know laser scanning, so I haven't got anything about how laser scanners work. If you do want to know about that, then the guys at the back from Murphy's or the Leica guy at the back will be able to tell you if you need to know more. So in terms of PAS 1192-2, this is always found interesting. In section 10.2, which is about handover, it actually says that. So it says, in addition, appropriate surveys such as point clouds or LiDAR shall be provided to verify the completeness of the as-constructed model. So this is within PAS 1192, and I think it's very valid. In the last year I was working at the survey company in the UK, I was involved in projects where the company would go in and scan a construction site as it was being constructed, and we called it progressive scanning. So we could analyse what the construction site was doing as it was going along. This was then validated in Revit, in various other software, to what was actually designed and the comparison made. Because the client at the end of the day wanted to know where his things were, and not to the millimetre, which it can be done with this equipment, but to the right room, to the right area, to the right space. So this is a bit of a video. It's hopefully it should work. There we go.
Building Information Modeling, BIM, is a proven process that keeps projects on time and on budget, reducing rework and increasing predictability and profitability. BIM has a solid return on investment with a 40% reduction in field changes, contract savings of 10%, and project time reduced by 7%. Moving from two-dimensional plan coordination to 3D model coordination is usually the first step. This allows contractors to spot and resolve potential problems. However, to fully maximize what BIM can do, it's important to connect the digital world with the real world. And Leica Geosystems can help. We are bridging the gap, taking BIM out of the office and into the field, and vice versa. Say hello to the BIM Field Trip, a comprehensive solution with hardware and software components that increases the BIM benefits for contractors. With renovation and retrofit jobs, the BIM Field Trip provides the most accurate field data using high-definition scanners to capture point clouds and total stations to capture discrete measurement points. Construction is then based on reality and not on outdated or inaccurate data. For new construction, the BIM Field Trip uses total station and multi-station technology to replicate BIM layout points in the field, providing accurate, real-world implementation. This paint-by-numbers approach is not only easy, but also very precise, unlike traditional, error-prone tools like paper drawings, tape measures, and plumb bobs. The BIM Field Trip technology offers a superior quality assurance solution with innovative multi-station technology that combines construction point layout and high-definition as-built scanning in a single hardware solution. As-built quality assurance point clouds are compared to the model to assess systems like MEP, providing insight critical to validating that buildings are being constructed as designed. Evaluating potential issues avoids rework in the field. Whether you are at a beginner, intermediate, or full service level of working with BIM processes, we'll help you explore all the benefits of the BIM Field Trip so you can lower waste, work more efficiently, reduce costs, increase profit margins, and maintain greater project safety.
On the next one. There we go. Okay, so in terms of the field trip and the benefits to various people, I probably don't think there's many traditional land surveyors in here. There may be a couple at the back from Murphy's. But in terms of what the benefits are to the various parties involved, I mean, as the video said, I mean, for a surveyor, using this kind of technology, you gain a hell of a lot of efficiencies. It's very quick and easy. I mean, in terms of Leica, we're selling more to architects and engineers for them to validate their own work. I mean, the scanners these days are very easy to operate, and on a very small scale are very accurate to what you want to do. So we're selling more to that in that instance. The fact it's such a robust 360 data set, you're unlikely to miss opportunities. In terms of architects, I mean, it's accurate and reliable as-built data. It's a 3D data set. It's not paper drawings. It's not 2D. It's a 3D point cloud, which you guys, probably quite a few of you have already seen and used in this room. In terms of engineers, it's to transfer critical data directly from the office environment to a guy on site without the need to email a paper drawing or to send a paper drawing, have them to work it out. These coordinates go directly into the turtle station for them to set it out. And in terms of contractors, I mean, monitoring the progress of your project as it's being constructed, reduce project costs and capture the as constructed environment. So in terms of the BIM field trip, in terms of bridging the gap, so we're taking reality from the field to the office, so this is scanning and then modelling. And then we add in construction points and take that back out into the site. And then what we can do then is verify that back into the model. So it's a full validated round trip from start to finish. So another video for you here. Probably about 5 minutes, something like that. Not much. So we have the as-built environment going on, and we have a requirement to capture this. This is a renovation project. So what we'll do, we'll go along as we'll take a laser scanner and scan internals and externals, which is even faster now with P20 and P15. We use the dedicated software, and then we can take that into BIM authoring software like Revit directly using the inbuilt engine or through a CloudWorks plugin that Leica provides with lots of tools. The model's created. The architect or the engineer comes along and creates the new part of the building. Construction layout points can then be added into there using Leica Building Link, which is a free plugin for Revit, which allows you to add in construction layout points. It can then go to all the various Leica turtle stations that you may already currently have, or your subcontractor might have, and it allows them to lay out the points directly onto the site. So this is getting away from the point of view of handing over paper drawings, sending through emails. In fact, you can actually send it as a file that goes directly into the turtle station, and it will allow them to set it out from there. And as well as that, you can send it back to the office to validate what's actually there. So the model that you've created is then updated if need be. See if I move. So in terms of what kind of projects, I mean, to inform and to scan is to, renovation projects, extend the building or even the infrastructure side of things. I mean, this is the main thing. It's not vertical, it's horizontal as well, so it's infrastructure as well as buildings. So there is a infrastructure link for Civils 3D if you're interested, which allows you to take construction points from Civil 3D into like a total station. So what we get today, so we have no data, older or inaccurate existing data, or we use 2D CAD plans. So how can 3D laser scanning help? So you scan the building, and it's a 3D data set to begin. It's accurate, it's reliable. I mean, you could have an actual sheet of paper saying that this scan is accurate to so many millimeters, and it's easy to visualize. It's a great place to start your modeling from, to start your project from. In terms of enriching, so what are the uses? So setting out concrete foundations, installing mechanical, electrical and plumbing. I mean, I've seen projects where they have a large industrialist site, and the guy's got loads of hangers for cable trays. Set up one total station in a matter of half an hour, can drill all the holes for it for the whole site, which would have taken potentially a couple of days from traditional. And this is all taken directly from the Revit model, from your authoring software, sent straight to the total station on site. So how is it done today? Paper drawings again, traditional turtle stations or even distos. So how can the construction layout help? Well, it's digitally created in the authoring tool, so it's signed off by you, sent directly to the turtle station, and the turtle station can pretty much turn to that location for the guy on site. So validation, so this is from the question, in terms of monitoring the progress of the project accurately, have an as-built record of what's there. I mean, from my past, from creating the models from scan data, what I always told my client was, you have scan data, that's the accurate data set. When you create models, you're adding inaccuracies to that scan data. You're making assumptions in terms of walls are horizontal, vertical, straight or curved. So what was always done was you hand over the scan data and the model. The model is your representation that you can use for your planning and so forth, but the scan data is there if you really want an accurate measurement. It matches, so you use both of them. And that was always a key for our clients, having both as a data set for two. So how can turtles so validate the construction process, links directly to the authoring tools, and same with the scanning, so scanning as it's going along. So 3D laser scanning, so you probably don't understand this, so it's the automation of 3D measurement data, can capture millions of points, can generate a point cloud, and can generate colour values. So the scan on the bottom here is actually a scan, that's not a photo, that's taken from Reading Football Club, which I probably doubt there's many fans in the room. So what are the benefits? It's accurate, quick, large and complex assets can be captured faster than ever before, and minimise site revisits. Ideal data set. So in terms of how do we do it? So laser scan, the as-built environment. We take it through Leica Cyclone, which is the processing. So we scan on site and we take all these scans together and register them into an accurate point cloud. We then use CloudWorks, which is another Leica software plugging directly into Revit gives you a big palette of tools to be able to model directly from the scan data very accurately. I'll skip through that. So in Rich, we have the Leica Building Link plugin, or we also have the Leica Infrastructure Link plugin. This is a free download which plugs in directly into Revit or Civils 3D, which you can add in construction layout points, code them however you want, and these can be sent directly to Leica total stations to lay out from site. As you see it, and then construction layout on site. So in terms of this, so taking method, so insert control points into the model. We can then insert layout points on the required feature. So we want to cut this hole in this wall. We export it and send it to the total station. We then use the resection part of the total station, and we can stake out these points automatically onto the site. So very quick and easy to do. In terms of validation, as constructed validation, so use total stations and scanners to scan the model, and then again use Building Link and CloudWorks within Revit or within Civil 3D to verify what you've constructed is exactly the same as your design. I thought I'd leave you with this picture. This is coming out in June. That's actually a backpack laser scanner. It's it will shrink in size slightly, but yeah. Yeah. But can you imagine the fact that you could walk around your site in a matter of 10 minutes and have an accurate scan cloud of a large construction site, and then upload it to your Revit, whatever authoring tool, in a matter of half an hour to analyse whether it's been constructed. I mean, we're seeing, and I'm seeing, a lot of demand from clients in terms of, I want to know that what you've constructed is correct and is the same as this digital model. And they're asking for a database of scan data, as it says in PAS 1192, to come along with these models to say, yes, what they've constructed is the same as what was designed. So that was very brief, but hopefully a quick overview of that.
Thanks, Mark.
Yeah.
Thank you very much.